This is video A25, and we are going to finish 13.2 today. This shouldn't take all that long. Okay. Normally I would teach you why this works later in the unit. I'm not sure if we have enough time to get to that this year. You will learn that next year though. Typically, what we're doing now has been part of a normal pre-calculus class. Just so you know, you usually go over all of this again. Okay, so here's a little rule. To find the values of the trig functions, like sine, cosecant, those, of any angle. So now we used to just be able to find trig functions for acute angles in a right triangle, but you notice that we've been working with angles that aren't acute. Okay, we have negative angles, we have 0-degree angles, we have huge angles. So we want to find the trig ratios. I really should have put ratios here. Later you'll talk about trig functions. This is what we do. Take any point on the terminal side, like we learned about. I don't know what I'm spelling there. And find the reference angle. Okay, just like we learned. Okay, the reference angle and the original angle will have the same trig ratios. Like I said, I doubt we'll get to the explanation of that this year. But let's see an example of this. Question 1. Negative 12, comma 5 is on the terminal side of angle theta. Find the 6 trig ratios for theta. Okay, so let's plot that point. Just do it approximately. It's not important to make this a work of art. Okay, so negative 12, 5, somewhere around there. We took a ray and rotated it. Here's the initial side. There's the terminal side. So here is theta. Okay, well, theta has there's a sine of theta. There's a value for that. There's a cosine of theta, a value for that. To find those values, form this reference angle. So we drop down there, make a right angle. And I'll go ahead and call this angle right here the reference angle alpha. Looks like a little fish. Okay. And if I can find alpha, I can find the trig ratios for theta. Okay, well, let's see what we know. Okay, I know that this leg right here of this reference triangle, it's 5 up. But, and this is important, to go from here to here, we went left. And it's 12 left, so I'm going to put a negative 12. Okay. Now for the trig ratios, I know I need all 3 sides, so I need to find the hypotenuse. I'll use the Pythagorean theorem, or some of you may recognize one of our Pythagorean triples that's fairly common. Okay, we're going to get a nice value for there, so I'll do that work right here. 5 squared, I'll call this h, plus negative 12 squared equals h squared. 25 plus 144. 169, and take the square root. That's a recognizable one. H is 13. Okay, so if I wanted to, I could write the sine of alpha, but what we learned up here is this reference angle and the angle of our interest right here, theta, will have the same trig ratios, and so I'm just jumping right to the answer. The sine of the angle of interest, look at the reference triangle, sine with SOHCAHTOA opposite over hypotenuse is 5 over 13. Well, immediately that must mean the cosecant of theta is the reciprocal, so 13 over 5. Okay, the cosine of theta with SOHCAHTOA, that's adjacent over hypotenuse. Now look, it's negative. So cosine of theta must be negative 12 over 13, making the secant of theta, the reciprocal, negative 13 over 12. And finally, the tangent of theta. Okay, the tangent with SOHCAHTOA, opposite over adjacent, so negative 5/12. And flip it over for the cotangent. And so it's adjacent over opposite, so negative 12/5. Okay, so let's move this up a little bit. Okay, and I'm going to work with this picture now. Okay, and so let's say I want to continue. Let's say I want to find theta using our calculator. Okay, and so I'll use the sine. The sine of theta is 5 over 13. And in geometry, you learned that in order to solve for theta, you have to use what we call the inverse sine. And you would just take the inverse sine of both sides. And remember, it looked like that. And we go to our calculator, and we remember that we have right above the sine, we have the inverse sine. Okay, make sure once again you're in degree mode. And all I have to do is hit second sine, and I get the inverse sine. And then 5 divided by 13. I hit enter, and it's telling me that theta is 22.6 degrees. And that's clearly not how big theta is. And so we have to think, what is that measure? Okay, that measure must be alpha. Okay, and alpha is what we would get if we went that whole way but subtracted theta. In other words, theta plus alpha add up to 180. Here, I'll even write that. You don't need to write this every time. Okay, and so alpha must be 22.6 degrees. I put the degrees in the wrong spot. And so we just use our calculator, and 180. Here, you know what I'm going to show you? 180 minus that answer right there. We do 180 minus, and there's answer right there. So hit second that, and I'll get the answer. And so theta must be 157.3 or 4, I'll put, degrees. Here's a question. What's the sine of that now? Well, what's your guess? And so let's see on here. Well, let's do the sine of this answer. So the sine of our answer, and it looks like it's uninteresting until I realize what's 5 divided by 13. And of course that makes sense. The sine of theta is 5/13. Okay, so now you should be able to do all of worksheet 13.2. I want you to do side B, and good luck with that, guys.